So now it's my pleasure to introduce the keynote speaker, which will talk to us about climate change and the oil and gas industry, a transition to a zero carbon world. It is Robert Perrons from Queensland University. Uh, I must share with you that Rob has delivered a number of lectures to the expert group Resource Management, and we are delighted to welcome him back for this exciting keynote. Rob is currently a professor of technology management and strategy at Queensland University of Technology in Brisbane, Australia. Rob, the floor is yours, and thank you for coming.
Teresa, thank you very much. It's my absolute pleasure to be giving this keynote today. And I very much regret that I can't be in Geneva. Geneva is a city that never disappoints at any time. But at this time of year, I find it particularly beautiful. And it would take a global pandemic and the cessation of most international travel to keep me away from Geneva at this time of year. But unfortunately, that's exactly where we find ourselves. I want to talk to you today, as Teresa indicated, about climate change in the oil and gas industry. And there are basically two key parts that I want to draw your attention to here. First of all, I'll put in front of you some confronting evidence that reminds us of the fact that even though we've heard a lot of exciting testimonial and there's a lot of great work that's happening that is going to help us on our journey in delivering on the promise of green and clean energy technologies, the transition is not happening as quickly as many of us were hoping it would. And a consequence of that is that we have to make sure that we're kind of doing our level best to try to think about carbon mitigation and carbon management also for the legacy energy assets that we have. So I'll be kind of investing the first half of the presentation talking about that. And I have great news for the second half, and that I will be giving what's basically tantamount to an update, a status update on where are we with new digital technologies that show tremendous promise in aiding and abetting our attempts to help with managing climate change, specifically with the oil and gas industry. Harry, advance to the next slide, please. Just a tipping of my hat to some research collaborators that I've been working with. A lot of the ideas and the themes that I'll be talking about here, even though I'm the one doing the talking today, these are based on many discussions that I've had with folks from the Intel Corporation and also from PwC, the global consulting company. Next slide, Harry. So basically, kind of let's talk about, here's a snapshot of what the energy mix of the world looks like more or less these days. This is this data that I'm presenting here is from as recently as a year ago. And among the things that we should be very pleased with, if we look on the right-hand side of this figure here, is that we see that the share of the overall energy mix that comes from renewables, we see that climbing very aggressively, very quickly. That's that orange line at the bottom of the right-hand side of the figure here. And that's what we were all hoping for. Now, but there's also some other news that we need to get on the table here. And that is that when we kind of look at how the other energy sources, the legacy ones, the ones that for decades we have relied on, like oil, like gas, we see that even though proportionally oil has kind of dropped in terms of what fraction of the overall energy mix comes from oil, we still see that in absolute exajoules delivered to the market. That's that green wedge on the left-hand side. We see that the absolute amount of oil delivered into the marketplace has not only, it's not level, it's still increasing. And natural gas is growing even faster than that. So there can be little doubt that oil and gas are going to be with us for at least the short to medium term future. Harry, next slide. And that is kind of crystallized into the following sound bites that we see from the International Energy Agency's most recent energy outlook. Yes, of course, they're very excited about the rise of solar and wind, et cetera. I don't think anyone is discouraging the arrival and the proliferation of these technologies, but the emerging consensus is that it's a little bit too soon to be talking about the absolute demise or the snuffing out of oil. It's going to be with us for quite some time yet, and that is even more true for natural gas, which is considered by many to be a transition fuel as we move to green and clean tech. Next slide, Harry. And that basically brings about a logical consequence of those things is this, that if we want to have a serious conversation about carbon mitigation, about achieving our climate goals, then those goals are not going to be at all within our reach if we're not also, in tandem to the new technology discussion, we also must be discussing the existing infrastructure, the legacy energy system that we have, that we've had for many decades. We're going to have to address how are we going to work towards carbon mitigation with those as well. Next slide. Okay, so let's just talk about what that energy, that legacy system looks like. And it also kind of puts into focus for us what is the size of the prize that we're talking about here. So this figure that I'm showing here, this is kind of the overall snapshot of where the global emissions come from or came from as recently as 2015. And basically what you see here kind of in that dark blue part towards the top of the figure is that this is the total greenhouse gas emission contribution that comes from the oil and gas sector. Now, the northeast part of that, the 33%, that comes from the using of fossil fuels, the using of oil and gas, the burning of them to create energy. Okay, now that's kind of to supplant that, to replace that or minimize it. That's going to be left in the hands of the people who consume these products. Okay, so that's really not what I'm focusing on here. What I do want to draw your attention to here is in the northwest corner, we've got that 8 and the 1, which adds up to 9, of course. So 9% of all the global greenhouse gas emissions come directly from the oil and gas industry. That is to say, this is the levers that they pull, this is the buttons that they push. So the oil and gas industry can directly control that 9%. And that's the 9% that I'm zooming in on with this talk. Next slide, please. So let's talk a little bit about the breakdown of exactly where these greenhouse gas contributions come from. When we kind of look at the spectrum, the soup to nuts breakdown of all of the different ways that greenhouse gases are emitted into the atmosphere, we see there's a bit of a mix here. We see CO2 at various parts of the process. CO2 is spat into the air. We see activities like flaring. We see here hydrogen production downstream, but there's this one very conspicuous baby blue chunk here that's 47%, almost half of the entire life cycle greenhouse gas emissions comes from this one curious section here called fugitive emissions or venting of methane. And I'd like to kind of talk a little bit about why that particular category is as big as it is. Next slide. That can be explained with two things here. First of all, we have to remember that a ton of emitted gas is not the same whether it's methane or CO2. The truth of the matter is that methane is at least 28 times more potent as a greenhouse gas than is carbon dioxide. 28 at a minimum, and there are estimates that it can be even more potent than that. So that's why it has this very outsized role, this outsized presence in when we kind of consider together all of the greenhouse gas emissions. Methane really stands out as a huge part of that problem. And I've also got, towards the top of the figure here, I've also got a recent headline from only a few weeks ago from the Financial Times of London, telling us that the methane pollution is starting to soar. In this particular article, they were talking about the U.S. with shale drilling, but I want to emphasize that just because that particular story was about the US. This is not isolated to the US. This is very much a global thing. But what I do want to draw your attention to there is that that the methane pollution levels are actually on the rise as the energy production has kind of bounced back in the post-COVID era, or we're turning the corner so that COVID's a little more behind us than it was. As the energy production is increasing, we are seeing that there is this significant growth in the amount of the methane that is being released into the atmosphere. And so that outsized chunk of the entire life cycle greenhouse gas emissions that the oil and gas industry was creating, it's in recent history, it's actually got a little bit worse. And this kind of emphasizes something that we already knew, that we already knew we had to be focusing on it. We had to be managing this. And what this shows us is that we have to do even better than that. We have to get very concerned about this because recently it got a little bit worse. Next slide. So basically, I've got this, the title of this slide talks about the other challenge. So we know what the challenge is. We know that in the long term, in the big picture, what we need to do is to take the global economy, take our resource system, and kind of move things to a place where green and clean tech is ubiquitous and everywhere. And I think we all get it. We all understand that that's the challenge. But the other challenge is while we are moving to that utopian future, we also have to be managing the legacy assets that we have. And just because of how slow it's taking us to turn this corner, we're going to have to, if we're going to have any serious shot at making things okay with our overall carbon mitigation strategy, we're going to have to devote significant time and energy and resources to managing the CO2 and methane outputs of the oil and gas industry. And so the question then is, what technologies, most specifically digital technologies, what can we bring to bear that will help us to achieve that? Next slide, please. Now, the great news here is that I think some of the heavy lifting is already done. We can significantly piggyback on some of the new design principles and approaches to engineering that have been unfolding in the oil and gas industry for the last few decades. The oil and gas sector has been working towards this concept of smart fields, and it kind of happened in fits and starts, and with slightly different nomenclature and different oil and gas companies around the world. But there was this idea took root of smart fields. Or I worked for Shell for many years, and so we called it smart fields there. It was called iFields at Chevron, digital oil field of the future at BP, et cetera. So this is, even though I'm kind of applying, I suppose, more Shell-friendly terminology there, it was a concept that most oil and gas companies grabbed onto. And so basically, we've kind of seen that this digital smart fields technology, these design principles and this philosophy, that this has been kind of getting absorbed throughout the industry for the last 20 years or so. So like I said, a lot of the heavy lifting is already done now, but here's where things are going to be a little bit different. Historically, the real motives, if we could be completely honest with ourselves about what was driving the absorption of this design change in the oil and gas sector, it was really driven by the pursuit of operational efficiencies and cost savings, delivering more barrels and making those barrels happen faster, cheaper, et cetera. Now, we can take those design philosophies, however, and we can kind of repurpose them so that we can kind of focus more on emissions and being greener. Next slide, please. One of the other big technological shifts that we see happening is that there's this this impressive shift towards the Internet of Things, okay? And one of the things that's driving that in the marketplace is we're seeing a precipitous decline in the price of sensor technology. Now, basically what that allows us to do is put our finger on the pulse of the patient and kind of build a bridge between the physical world and the digital world. And so we can kind of measure whatever technical parameter we wanted to keep our eye on. What's the flow rate over there? What's the temperature over there? What's the pressure in that manifold? We can basically pick whatever technical parameter we want to measure at any point in the system, and for what is a reasonable and very affordable amount of money, we can now measure it, and we can record that data and share it with any stakeholder that might care about it. And what this does for us is it gives us a much greater degree of enterprise-wide visibility and transparency, so that everybody in the system is able to basically look at what is happening at any point in the technical system that we're talking about. Next slide, please. Another big important development that I'm excited to tell you about today is that we're seeing more and better penetration of edge computing. Now, let me just kind of explain what I mean by edge computing. This is basically we're kind of moving the computation functions to the edge of the network, that is to say, closer to where the data is being collected. If we kind of think about the smart fields paradigm or the intelligent oil fields paradigm that we've been developing over the last couple of decades, really a lot of that was about collecting data at the wellhead or wherever the production was happening. And then the data would usually get sent to some, cloud type of environment, and then calculations would happen, and then the results of those calculations would eventually find their way back to the operational area where this stuff was happening. And then we were there was always this latency or this lag, this time lag between when an event happened and when we got feedback on that event. Now, the bad news there is that sometimes this meant that we were not able to optimize in what would be a helpful time frame, or we couldn't optimize in real time. And that would prevent us sometimes from being on top of situations where we could have stopped an emission from happening. But with edge computing, it helps us to reduce that latency. It gets rid of a lot of that time lag. And why that is extremely beneficial in this context is it means that the system overall will be much better at reacting much sooner to emission type of situations. So instead of just finding out after the fact, geez, we really should have been on top of that. We could have managed it differently here and here. If only we had that information at the time. Now we have that information, the calculations that we need to make that more informed choice. That's right in your hand, right out of the blocks. And also by having the calculations happening where the production is happening, it also makes the whole thing simpler to audit. Next slide, Harry. And that brings me to this. We've seen over the last couple of years the emergence of a global data standard called the Open Footprint Forum. Just a few words about what that's about. What this allows us to do is it's basically a framework for sharing information, a protocol, if you will. It's an architecture for how we think and talk about and categorize emissions. And it was kind of originally designed for all kinds of industries, but it's been specifically absorbed and is being used extensively by the oil and gas sector. Many international oil companies, many national oil companies, most service companies, and lots of digital vendors have all piled in. And so this has kind of become, I think it's fair to say, this is kind of the standard for this. And what this allows us to do now is have a shared language within the entire industry and a framework for being able to share data. And companies can work together to make sure that, again, soup to nuts, that we are able to kind of let the data flow throughout the entire value network from one company to the next, and make sure that we are able to measure very accurately and very carefully exactly where emissions are happening. And it's by having that greater degree of transparency and visibility, that's how we're going to manage this better in the future. Next slide. I think I'm just about out of time. Thank you very much for giving me this opportunity to share these ideas with you and to bring you up to speed with some of these technological developments. It's been my absolute pleasure. If you have any questions, I'll do my level best to answer. Thank you.
Thank you. Thank you, Robert, for your very, very interesting presentation and enlightening us in our work and putting very interesting questions.